Okay, everyone, let's go ahead and get started. It's nice to see so many people. Who is here for the first time? Awesome, welcome. Who's been here before? Wonderful. See, it's a perfect mix. I love it. Okay, so my name is Pia Sorensen. This is the Science of Cooking public lecture series, and I'm just about to introduce Joanne Chang, which I know is the reason you're here. But what I usually do for those of you who are new is I usually say just a few words to put what Joanne is going to do, or whoever the speaker is, what they're going to do, in some kind of scientific context. And for those of you who've been before, you know that this lecture series is modeled after an actual class, which happens in the room next door tomorrow. And so we try to focus on the theme of the week that is the theme in that class. So the theme of this week is mouthfeel. You can't talk about food without talking about mouthfeel. So far, we've talked about phase transitions and fermentation and flavor, but what about mouthfeel? What is a food if it doesn't have the proper mouthfeel? So these here, okay, let me check this. Who's been to one of Joanne's lectures before? Yeah, so then you know, welcome back, then you know that some of the foods she has made, and some of them we're going to see again, include things like yellow birthday cake, amazing egg white foams, pralines, so just like really brittle sugar, and this amazing thing here, which I'm not going to give away, but it's very brittle and very beautiful and very scientific. Okay, so all of these completely different mouthfeels, completely different. And if you kind of think of each one and you had to describe it, it would probably be a little challenging. And my job here is to basically see if we can get a start by trying to describe some of these mouthfeels with an equation. So how would we quantify these different mouthfeels? And we're not going to get all the way because mouthfeel is super complicated, but I want to give you just something for sort of a first idea that you can play with. Okay, so science. Remember from physics class, remember spring, right? So springs have squishiness. And if you who remembers, it rings a bell? Okay, good, a little bit. So if you saw this spring, and if not, that's okay. The whole point is basically that in physics class you discuss these springs, and you can kind of get a sense for how stiff the spring is, depending on how much force you pull on it with, and how much it then deforms. So how much does it stretch out? And this we call the spring constant. So you can imagine a very stiff spring, and I'm going to have to pull really, really hard, or one of these wonderful sort of stretchy springs, and it's going to be very easy to pull, right? Different kinds. Okay, there's a spring. This is a steak. Oh, and you clap. Okay, so if you're new, we clap for equations. Let's clap. Okay, so this is the equation of the week. And what this equation basically does is it takes this spring constant and it just adapts it to a food. So what you do here, see, it squishes down just like a spring. You see that? Let me do it again. See, it squishes down just like a spring. And you can imagine any kind of food there. You can take Joanne's yellow birthday cake. You can take her sticky bun. You can take anything and put it under this weight, and it will have a springiness. And that is kind of a model for what happens in your mouth as you bite into it, right? That is what happens when you bite into it. Those are your teeth. And at some point it breaks, and then that's a different equation, but that is kind of the first spot. And if something is very hard, like if you take a piece of the praline, at the end you're going to have to put a lot of force, like really bite down, to get even just the slightest little deformation. And if you take the amazing foam that Joanne is going to make, you're just going to have to sort of just barely touch it, and it sort of spreads in your mouth. But it's that idea that is there as it squishes together. So the way you could measure this, okay, so here's the equation again. Basically what it said, okay, yeah, let's clap. Why not? It's fun. It's good. Good. So basically what it says, just to summarize, is you take some kind of force which depends on how much weight you put on the food. And then you want to normalize that over the area. So if you have a very big steak, then you need to basically take that into account. But if you just have a little piece of food, but you have the same area, then you want to know that as well. And then you divide that by how much it deformed, so the delta L, how much it sort of squished down, and you divide it by the original height. Okay, let me just say it again. So the force over the area, that's basically the stretchiness of the spring, and then you divide it by how much it deforms, and in order to kind of normalize it, you divide that number by how tall it was to begin with. And that's the equation. And you could basically do it like this. So you can now go into your kitchen, you can go home, you can take some weights you have, you can take a piece of food, cut it out perfectly, measure how big it is, measure the area, and you put this weight on top, you calculate the force from that, then you measure how much it is to start and how much it is after you put the force on, and that would give you this E, which we call the elastic modulus. It's as squishy it is. It's a fancy word. You can go out, go home and talk about your food, like, oh, the elastic modulus, so good. My steak, so good. Okay, so what I want you to do, basically, as we go through this lecture, think about this and think about it for all the different textures and see how this equation applies. And then we can talk about it afterwards. Okay, so with that, I'm going to introduce Joanne. So we calculated this before. We think this is the 14th year.
I think I've been doing this since.
So Joanne is not only a legend in Boston, she's also a legend in this series of Flour Bakery and Cafe, Maillard and Chang. It is always a huge honor to have her here. So let's welcome her warmly.
Thank you, Pia. Thank you so much. Thank you. I'm so happy to be here. As Pia said, I think it's my 14th time. I started out teaching how to make the perfect birthday cake, and then it segued into the science of sugar. So I have a question before we get started. How many of you are here because you're bakers and you're hoping to learn a little bit about baking? I'd love to see all the fellow bakers in here. Excellent. I got my eyes on you. And how many of you are scientists wanting to learn a little bit about the science of sugar? Wow, amazing, awesome. Okay, and then how many of you have heard that I've done this for many years and that there's treats and you came for something sweet? It is dinner time after all. Excellent. So some of you have already gotten some sweets and we are going to be passing them out later as well. Well, I want to thank Pia and Harvard for having me, and I also want to thank my assistant Coco, who put together all of the sweets that you're going to be enjoying. So I'm thrilled to be here. Let me start by sharing a story on how flour got put on the map. So it was back in 2007, and the Food Network reached out to me and said that they wanted me to film the pilot episode of a brand new series that they were starting called The Science of Sweets. Now, I have a math background. I graduated from here with a degree in applied math economics, and I am obsessed with sweets. And so the idea of doing a show on the science of sweets was really appealing to me. So the first day, you can see from the video, they had me in a green room where they had a big whiteboard, and they had me bring a bunch of sticky buns to the green room. And there was this big whiteboard, and then they had me writing all of these equations. I wrote down the Fermat's theorem, I wrote down the Fibonacci sequence, I wrote down the quadratic formula, and I kept thinking to myself, this has nothing to do with baking. But they're the professionals, so I'm just gonna keep going, and we're gonna just roll with this. They also had me behind a big placard, a big green sign called The Science of Sweets. And I would sit there with the sign in front of me, hiding my face, and I would pop out at literally every single angle imaginable, The Science of Sweets, The Science of Sweets, The Science of Sweets. So after a full day of this, you can imagine, I'm so excited that we are filming this episode and that it's going to be the next great hit on the Food Network. So the next day, we go to one of our bakeries. This was in 2007, and we had just opened our second bakery in Fort Point. And they invite 100 Harvard students to come and watch me prepare sticky buns. So I'm preparing sticky buns, and I am making these sticky buns, and I look up because everybody's cheering, and Bobby Flay walks in. So Bobby Flay is a chef who has a bunch of TV shows, and at the time he had a show called Throwdown with Bobby Flay. And in this show, he goes around the nation and he challenges chefs to one of their specialties. So in here, he's telling me that he's going to challenge me to a throwdown for sticky buns. Now, what you don't see in this clip is that I am convinced, because of the day prior, that we are filming The Science of Sweets. So when he walks in and he challenges me to a throwdown, I say to him off camera, I'm like, no, we can do that later, but right now, I'm doing The Science of Sweets. So they have to stop the camera and say, no, there's actually no Science of Sweets. Exactly. You're actually filming a throwdown. And I thought, but what happened to everything from yesterday? They said, no, that was just to fool you. And I was like, okay, well, you fooled me. So he had been off camera making sticky buns at another kitchen while I was in my bakery making sticky buns for what I thought was The Science of Sweets. Then we do a blind taste test with the 100 Harvard students who had been invited to come watch. And then there were some judges. It's not staged at all, so you have no idea who's going to win. And in fact, I don't think you can see in this clip, but I'm so nervous when they're trying to decide who's going to win. They've got my hand in one judge's hand and then his hand in the other hand. And then they finally say, and the winner is, and then they put up my hand, and it's Flour Bakery. So our sticky buns end up winning. And that is what put us on the map. Thank you. So that was a huge thrill, obviously. It changed the trajectory of Flour Bakery and of my future, my career, because it did put us on the map, and instantly hundreds of people, thousands of people from across the country wanted to come to Boston to try these sticky buns. So I was so grateful to be featured in that show because of all the great things it did for our business. But at the same time, I was bummed, as I can tell many of you were, that we weren't actually filming a show called The Science of Sweets. I am so fascinated and passionate and enamored by how science and baking come together, and especially sugar, that if I were to actually film this show, The Science of Sweets, I think my first episode ideally would be about sugar and the role that sugar plays. And in fact, I love thinking and working with sugar so much that I wrote a book called Baking with Less Sugar in, I think it came out in 2013. So yes, so I have a book called Baking with Less Sugar that's filled with recipes that are made with less sugar or natural sugars. Now, in writing, the thing about sugar is that we are engineered to love sweets. When you give a baby something sweet, they always smile. You take a brand newborn baby and you put a little sugar water on your finger and you put it to their mouth and they instantly smile. There's the opposite effect if you give them something that's bitter or sour. We are engineered, again, to view something bitter or sour as dangerous. We are so fascinated and in love with sweets that we end every meal, we tend to end many meals with dessert. And what is it that makes a dessert a dessert? Well, it's probably sugar. You can think of a couple of things that you might end your meal with that don't contain sugar. So I've got fresh fruit and I have cheese. Two things that don't contain actual sugar that we sometimes end the meal with. But I think if I were to ask most of you here, the way that we actually want to end our meals is with dessert. Okay, so now I have 4 aprons that I'm going to give away because I want to ask you all a question. When I started writing the book, The Science of Baking with Less Sugar, I really thought that the biggest challenge was going to be how do I trick my palate so that I'm not using sugar, but it still tastes sweet? You know, do I add more cinnamon? Do I add a little vanilla extract? Do I use some fruit juices? And I really thought that was going to be the biggest challenge, is making something taste sweet without sugar. And I thought that's why sugar is so important in desserts. But now I want to ask all of you, because I learned in writing this book that adding sweetness is only one of the many roles that sugar plays in making a dessert amazing. So I would love to hear from you. Can you think of any dessert, any sweet treat in which the only role that sugar is playing is to make it sweet? Yes? Meringue needs sugar for sweetness, but it also needs sugar for something else, which we're going to go into. Yes?
Maybe like creme brulee, the topping of it?
So the topping of the creme brulee, you actually do need the sugar, not just for sweetness, but actually to make the caramel, which we will also talk about. Other desserts, yes?
Powdered sugar on top of a donut?
Powdered sugar on top of a donut. Yeah, I think that counts as, a way that you can use sugar in which the only thing the sugar is doing is making the dessert sweet. So it's not actually playing any other role. Other ideas, yes? Churros, meaning in the dough?
Outside?
So I feel like that's kind of like the powdered sugar. Yes? Jello. Okay, okay, we're gonna give you the apron. Actually, yes, Jello. If I click, then the Jello's gonna come, but then all the other answers are gonna come. So I'm gonna. Other things, yes?
What about popsicles?
Popsicles. No, you don't get an apron, but it's a really great guess. A lot of people think that the only role that sugar is playing is to make it sweet, but we're gonna find out why that's not true. Yes? Marshmallows. Again, it's a great guess, but it's not the only thing that sugar is doing. Yes? Ice cream is in the same category as popsicles, so not quite. Yes?
How about like simple syrups, like in different drinks?
Yes. I mean, yeah, that works. If you want to just make a simple syrup and add it to a drink, the only thing that the sugar is doing is making it sweet. Yes?
Whipped cream.
Whipped cream. Yes. Last apron. Okay. I'm going to try and throw this. Yay! So here are the desserts that we've come up with in doing this series for 14 years of desserts in which the only role sugar is playing is to make it sweet. So you have chocolate. If you take unsweetened chocolate and you add sugar to it, then you get sweetened or bittersweet chocolate, and that you could eat as a dessert. Sweetening adding sugar to whipped cream and putting it on top of fruit, for example, that makes something sweet, and then it's palatable, and then we view that as a nice way to end a meal. Yogurt, if you stir in a little bit of sugar or honey into it, then that's another example of a dessert or a sweet treat in which the only role that sugar is playing is to make it taste sweet. Jell-O, I think you mentioned Jell-O. And then cheesecake. If you have a cheesecake and you don't add sugar to it, or if you add sugar to it, the only thing that's different is that the sweet cheesecake, which is the one that is dessert, the sugar is making it sweet. So it is interesting that of all of the guesses, we didn't touch on every single one of the things that sugar does, because there are so many other things that sugar does to make a dessert amazing. There are 7 reasons that we're going to go through today to show you what role that sugar plays in making a dessert great. Okay, the first one is, so this is where the baking part of the lecture starts. So if you're a baker, then you've probably creamed butter and sugar together in a bowl, right? You start off pretty much every cake or cookie recipe with cream, butter, and sugar together in a bowl with a wooden spoon, or use a KitchenAid mixer. So what is that doing? So the sugar in the butter is acting just like a gardener would after a long cold winter in New England. So we're just about to enter winter in New England. And come May or June, if you're a gardener, you're going to go into your backyard and you're going to realize that the earth has been packed frozen solid off and on over the past many months, and you need to take a garden hoe to aerate it, right? So that's exactly what we do when we mix sugar with butter. If you take sugar and look at it in a microscope and bring it all the way down, it's a crystal We've all seen this in science class. Sugar is a crystal. And so that crystal, when it goes into butter, is acting like hundreds and hundreds and thousands of little workers with shovels that are digging little holes and aerating the butter. Now, why is that so important? When you have a block of butter, and if you just take that block of butter and add it to a cake batter or a cookie batter, if you don't aerate it, then you're not giving the cake batter any sort of lift. Then even if you put in baking powder or baking soda, there's actually no air inside the butter, inside the batter, that the baking soda or baking powder can act upon to create gas that causes your cake batter to rise. And so creaming butter and sugar together aerates the butter. It creates millions and millions of tiny microscopic air pockets within the butter. That butter then mixes with your flour, your baking powder, your baking soda, whatever other things that you have in your cake batter. And then it's all of those air pockets that react to the baking soda, baking powder, and those air pockets that lift up. And that's what causes your cake or your cookie to be light and fluffy. So here's a picture of butter and sugar before creaming, and then after. Before creaming, it's kind of clumpy and it's pretty yellow. And then after creaming, it becomes a lot lighter. And in fact, the word creaming, when you talk about creaming butter and sugar together, it comes from heavy cream. Heavy cream, its color is a pale cream color. And so that's why after you cream butter and sugar together, it turns pale. So we have butter and sugar that have been creamed, and then we have these cakes that we've made. And you can guess which one was made with creamed butter and sugar and which one was made with butter and sugar that were not creamed. And you can see that when you don't cream the butter and sugar together, the cake batter doesn't have any air pockets in it. And then when it goes into the oven, it tends to just bake solid. You need the creaming action to create all the air pockets that allows you to create a fluffy cake. Okay, so that's reason number one that how sugar helps make desserts amazing. Another way in which sugar is important in baking is sugar is hygroscopic. So what does that mean? That means that sugar loves to attract moisture. And sugar just takes all the water that's in the air and then brings it to itself. So it's the reason why you can take an Entenmann's that's been sitting on the shelf. I mean, there's also a lot of preservatives, but there's a lot of sugar in these desserts, and the sugar is constantly attracting moisture in the air, bringing it to itself, and allowing the pastry to stay moist. The more sugary your pastry, the longer shelf life it'll have. If you have a pastry that's low in sugar, then the shelf life is probably just a couple of hours. When I wrote Baking with Less Sugar, one of my hopes was that we could take some of these recipes and bring them to the bakery and sell them. But unfortunately, this was one of the reasons why we couldn't, because the pastries themselves only tasted great for about 4 or 5 hours. And oftentimes, the baking would be done at like 5 in the morning, and then it would stay on the counter until possibly, 5 in the afternoon. And by then, anything that didn't have a lot of sugar in it had dried out. So we weren't able to add those items to our counter. Okay, another reason that sugar is important in baking is that sugar lowers the freezing point of frozen desserts. So the popsicle, the ice cream. So let's think about this. We are now in October, and in about 2 months, probably 2, maybe 3 months if we're lucky, we're going to start seeing a lot of snow, right? And the snow is going to be all over the roads. And what's the first thing that the plows do as soon as it starts snowing? They start sprinkling salt onto the roads. And why do they do this? They do this because salt lowers the freezing temperature, right? Water, as we all know, you put a cup of water into the freezer, it's going to freeze at 32 degrees Fahrenheit, 0 degrees Celsius. If you can add something to the water so that it doesn't freeze solid at 32 degrees, but maybe it freezes at 20 degrees or 10 degrees, then that's going to allow you to cause the snow and the ice on the road to turn to slush, and it's going to make it easier for us to drive to work. Sugar does the exact same thing. Sugar lowers the freezing point so that if you take a cup of water and just throw it into the freezer, it's going to freeze solid, but if you add sugar to it, it's going to depress the freezing temperature, and then this water, it will be simple syrup by then, sugar syrup, it won't freeze rock hard. And so that's why it's so important to have sugar in popsicles and in ice cream, because without it, if you try to eat whatever it is that frozen dessert, it'll be rock hard. Like nobody wants to bite into an ice cube. That's not very pleasant. Sugar is what allows you to have a creamy dessert. So I'm going to show you this video. This experiment was done about 14 years ago, so I think the video quality isn't grand, but this is what we had 14 years ago. So this is grapefruit sorbet, or it's grapefruit juice that was frozen solid, and you can see that we can barely scrape it. Then we took a cup of grapefruit juice and we added half a cup of sugar. And you can see with the spoon, it's a little bit more smushable. What's the right word? Pliable, elastic. But then you add a cup of sugar, and you can see that you can actually spoon it up. You add 1.5 cups of sugar, and not only can you spoon it up, but you can see that it's started to become really liquid. And then the last is with 2 cups of sugar, and it's pretty much just like slush. So the role that sugar plays is to allow you to take a frozen item and play around with the texture so that it's something that you can spoon up and enjoy and eat. This was a big challenge in writing Baking with Less Sugar, because I wanted to put in some ice creams and some sorbets, but I couldn't add sugar because the whole point of the book was to not use sugar. And so one trick is, and obviously I wasn't going to put a lot of salt in the sorbet. That's not going to make it good. But one trick, what do you think is a thing that you can add to a frozen dessert that's not sugar or salt that allows it to be soft? Yes? Say it again? Oh, xanthan gum. Possibly, but I don't know. It probably is. I just don't know enough about like that type of baking. Alcohol, exactly. Think about, do any of you store your vodka in the freezer for like really cold drinks? So if you put a bottle of vodka in the freezer, it won't freeze solid because it depresses the freezing temperature of a liquid. So in Baking with Less Sugar, I had a chocolate ice cream recipe that I was really hoping to be able to put in the book. But every time I made the ice cream, it was too hard. It wasn't enjoyable at all. And so I added a big splash of bourbon, and then it became great. Okay, another thing that sugar does, and I think somebody had mentioned meringue. Another thing that sugar does is that it stabilizes beaten egg foams. So I'm going to talk about it, and then we're going to do a quick demo. So we got lemon meringue pie. That is a egg white meringue. Meringue is white egg whites and sugar. Then we have angel food cake, and we have buttercream. So egg whites are mostly proteins, right? Like think about like when you eat an egg white omelet and you cook the egg white omelet. Without the egg yolk, it's just this rubbery thing. Egg whites are mostly proteins, which in their liquid, uncooked form are like little rubber bands almost within the egg whites. And when you whip egg whites in a mixer, which we're going to do in a minute, the rubber bands stretch, and they keep stretching and stretching. And so imagine if you take your backpack and you throw in like a 1,000-count bag of rubber bands, and then you walk, across the yard. By the time you get to the other side of the yard, all the rubber bands have kind of started to find each other, and then they get all tangled up, and they're kind of like this big ball. When you whip egg whites, the same thing is happening. You've got all these strands, these like stretchy protein strands. And because you're whipping them and whipping them, they start to catch each other, and they start to like attach to each other. And then what they do is that they attach to each other, and they actually form bubbles within themselves. And when you whip up egg whites, initially what you get is, you get, this is a cup of egg whites. So it starts off as gloppy yellow, and then it turns white and foamy, right? In fact, let's go ahead and just get some of this started. So I'm going to do 1 cup of egg whites here and another cup here. And I'm just going to turn both of them on while I explain a little bit more about what happens. So the egg whites are yellow. They're viscous. As we add air to them, those protein strands start to catch each other. They start to aerate. It starts to get white and foamy, and it eventually starts to look like shaving cream, which I'll show you in a second. Without sugar, what happens is you whip, 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 you get the shaving cream look. If you pour that out into a bowl, eventually all of those bubbles, they're only so strong before they start to collapse. And then they collapse, and then the foam gets like stiff, like styrofoam, and then all the water kind of falls out, which I will show you. So what does sugar do? If you add sugar to the egg whites, the sugar mixes with the water that's in the egg whites, and it forms a simple syrup within the egg whites. And then that simple syrup actually surrounds all of the bubbles. It's like packing peanuts when you're taking something really fragile and trying to send it, across the country to California. You would never take a fragile item and just put it in a box and send it. You pack the box with peanuts, make sure it's nicely cushioned, and then send it. And that's exactly what sugar does, is sugar is protecting all of the bubbles so that they don't pop and that the water doesn't leach out. And so then that stabilizes the egg foams. And once you have stable egg foams, then you can make lemon meringue pie, you can make angel food cake, you can make buttercream. So what I'm going to do here is I'm whipping up 2 different bowls of egg whites. And in one bowl, I'm not going to add any sugar. And in the second bowl, I have a cup of sugar. So it's a 1-to-1 ratio, just for this experiment. But you really don't even need to add that much, and it'll help stabilize the egg foam. So I'm just slowly adding the sugar to the egg whites. And as soon as I add the sugar to the egg whites, I know that you probably can't hear because they're both really loud, but the whisk takes on a different sound because it starts to immediately become more glossy. That sugar is mixing with the water, and it's creating this syrup, and it's just allowing the whole mixture to be just a little bit like oozier, which then makes a different sound in the mixer. It also makes a little bit of a different appearance. And I don't know, can you guys see? You can't see. Okay, I'll show you as soon as they're done. But the one that has no sugar, it's just foamy. And the one with sugar starts to get really, really glossy. Okay, great. Okay. So you can see in the camera that this one is really glossy. And we're going to whip it until it gets kind of stiff. And then this one is nice and foamy, but I wouldn't describe it as glossy. Okay, so I'm going to show you this one, which is just egg whites. And then I'm going to dump it out in here. And somebody has to remind me at the end of the lecture, we're going to look at it, because you will see the difference. But it's going to take probably about 10 or 15 minutes. So this is just egg whites, no sugar. And then I'll show you this beautiful meringue. Can you see the difference? I don't know if you can tell from there, but you'll definitely be able to tell a difference in about 10 minutes. This is like a soft peak meringue. And again, what's happened is all of that sugar has just formed a syrup that is now protecting all of the egg whites, all of the air bubbles. Yeah, so you can already kind of see how this one is starting to leach a little bit of water, and this one is a lot glossier and whiter. So that is a big part of sugar in baking. It stabilizes these egg foams, and then you can make all of these beautiful desserts. Okay, another thing that sugar does is it aids in browning. As soon as you add sugar to a baked dessert and then put it in the oven, the Maillard reaction happens. And part of the Maillard reaction is that the sugars and the proteins are connecting, and then it actually creates these ring-like structures within the pastry that reflect light differently. And they reflect light in a way that is pleasing to our eye. And so you can see on the left is a picture of our sour cream coffee cake at Flour Bakery. This was taken for the first Flour Bakery book, and this recipe has about a cup and a quarter sugar in one coffee cake. So in baking with less sugar, I challenged myself to make a version of our coffee cake that tasted just as great, but only has 6 tablespoons of sugar. And so there's a lot of little tricks in here. Like I said earlier, there's a lot of cinnamon, there's a lot of vanilla, et cetera, et cetera. But when I baked it, the one thing that I couldn't figure out how to do, short of putting some sort of like glaze on top, which would defeat the whole idea of less sugar, was I couldn't get the cake to look nice. It wouldn't brown because it didn't have enough sugar. And so when we were taking all of these pictures, you're doing the photo shoot for a cookbook, and it usually takes like 3 or 4 or 5 days. And you take the pictures, and at the end of the day, you upload them and you send them to your publisher, and then they give you feedback. And then the next day you come back and you take more pictures, and you're always trying to make them better. And immediately they were like, oh, no, this isn't going to work. You cannot print this picture because it doesn't look good. And so they wanted to Photoshop it. They wanted me to come up with a glaze. They wanted me to overbake it so that it just kind of burned and looked brown. And I let them know that we couldn't do that because then if you were baking this cake at home, you would be expecting something brown and beautiful, and that's not what you're going to get. And so sugar plays a key role in making something look delicious to us. And as we know, we eat with our eyes. And so not having sugar makes something less palatable. Okay, how many of you during the pandemic got into bread baking? It became a thing, right? All of a sudden I became surrounded by so many bread bakers. It was really amazing. So if you are a bread baker, you know that you mix flour and water together, and then you add other things, right? You add yeast or you add salt and sugar, but essentially it's flour and water. And what happens if you just take flour and water and mix it together? At first, it's just kind of like this muddy, slushy thing. But eventually, what happens is it starts to get stretchy. And it's an amazing thing about bread baking is that you can just take water and flour and put it together and wait. And if you wait and wait and wait and just keep picking it up, it'll eventually start to be stretchy. It won't be like a mass of stuff. It'll start to actually feel a little bit like a bread dough. And that's because, and so when you were baking, you probably read a little bit about flour content, or protein content in flours, right? If you have a flour that has a high protein content, then that's really advantageous to bread baking. And conversely, if you have a flour that has low protein content, it's really good for cakes. So why is that all important, and how does sugar play into all of this? So protein strands, very similar as in egg whites, there are these little strands within the flour that we can't see. And there's 2 protein strands within wheat flour. One is called glutenin, and the other is called gliadin. And when glutenin and gliadin in the flour are mixed with water or liquid, it causes them to connect to each other like magnets. The water creates this what's not really a magnetic force. I have to be careful in a science class not to use that word freely, but it connects the glutenin and gliadin strands together. And as they connect, similar to the egg whites, they start to just form like little webs. And so bread dough is not just flour and water. You also need to add yeast, or some sort of sourdough starter or something. And so what is yeast other than a microorganism that feeds off of sugars, and as it feeds, just like people, it gives off gas. It basically, once it eats, it burps and it farts. And it's sitting there in your bread dough, and it's giving off gas. And the gas is then causing the dough to rise because all of the glutenin and gliadin strands have connected. And you've created all of these pockets, which then the gas fills up. And that's what gives you this beautiful loaf of bread that's full of air and is chewy and is amazing. So all of that is great, but not what you want when you eat a cake. When you eat a cake, you don't want a chewy, dense, thick, rich cake. You want something that's tender and that melts in your mouth. So how do we do that with sugar? Go back to flour and water mixing together with the glutenin and the gliadin strands starting to connect. As soon as you add sugar, the sugar stops the connection. The sugar goes up in between all the strands and it's like, nope, 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 I'm not gonna do it, I'm not gonna let you. And so then your cake batter, which has sugar in it, prevents the flour, the protein strands in the flour from connecting. Every cake batter has either milk or buttermilk or some sort of liquid. You need some sort of liquid in order to make it a batter. And that liquid is not your friend when you're trying to make a tender cake because liquid and flour will cause gluten development. But then you add sugar, and then the sugar becomes your best friend because it prevents the gluten from developing. So that is a hugely important role that sugar plays in baking that we often don't think about, but that we definitely experience when we eat a cake. And then finally, and I think somebody had mentioned creme caramel, the creme brulee, the sugar on top. But sugar makes pastries crispy. Sugar, once you put it into the oven and it starts to caramelize, and then when it cools, you get something that's crispy. So whether it's on top of a creme brulee or in a cookie, that sugar caramelizing and crystallizing, then once it cools down, is what gives you the snap of a sugar cookie. And so I think we're gonna be passing out, what you'll get is a little cup that has some buttercream, which I'm gonna make right now. I'm gonna show you how to make buttercream with a little bit of caramel sauce and then a crispy sugar cookie. So let me start first with making what we call, we're gonna do an Italian meringue buttercream, yes. So I have in here, I have sugar that I've added a little bit of water to so that I've made it into a syrup. And I'm just gonna turn that on and bring that to a boil. Then over here, I have my mixer with egg whites. And what I'm going to do is I'm gonna walk you through the different stages that sugar syrups go through. And then when we get to the right stage, when this pot of water turns to the right stage, then we're gonna use it to make buttercream. So I actually wanna go back to the video, or to the PowerPoint. Get all of these going. Okay, so that was the setup. While we're waiting for all of this, let me walk you through the stages of sugar. So if you take water and you boil it, what temperature is it at? I wish I had one more apron, but we all know this answer, right? What temperature does water boil at? 212, right? So 100 degrees Celsius, 212 Fahrenheit. Did you know that if you add sugar to water, you can actually, okay, so you boil a pot of water and it goes to 212. Can you get it any higher than that? Without adding anything to it? No, right? You can boil that pot of water all day long and it's gonna sit at 212. So how can we actually make that liquid hotter than 212 degrees? You add sugar to it. If you add sugar to it, we go through the stages of sugar. So first we have thread stage, and I think somebody mentioned making a simple syrup to add to drinks. When you add sugar to water and boil it and bring it up to about 230 degrees, this is what's called thread stage. I mean, to all of us, it's just sugar water. It's melted sugar water, and you would use this to sweeten drinks for the most part. But then, as you continue to boil the sugar syrup, the water starts to evaporate and the sugar syrup starts to concentrate. And then you can actually continue to raise the temperature of that liquid way past 212 and way past 230. So the next stage is called softball stage. Softball stage is when the sugar syrup reaches about 238 degrees. At this point, the syrup is 238 degrees, and if you take a little bit of the syrup and you put it in a cup of ice water, it forms a little soft ball. And that syrup then can be used to make fudge and to make buttercream, which is what we're going to do in just a little bit. Keep boiling that sugar syrup, and you can get it up to firm ball stage, about 245 to 250 degrees. So firm ball stage, again, you just have to keep boiling this sugar water. As it gets to firm ball stage, then when you take a little bit of it, the reason that it gets its name by taking a little bit of the sugar syrup, putting it in some ice water, and then you get a little firm ball, one that won't squish. And you can use that to make caramels, soft caramels. Keep boiling that sugar, and you get to what's called, hold on, this stopped. It did stop. This happens often where there's too much electricity going on. So if you keep boiling the sugar syrup, it eventually gets to 250, 260 degrees, and this is the hard ball stage. If you take some of the sugar syrup and you put it into ice water, you get a hard ball that doesn't squish at all and is actually hard enough to knock on a table. And this is what we use to make nougat, for example. Keep boiling it, and you get to soft crack at about 270, 280 degrees. And this is what we use to make toffee. Boil it, keep on going, and it goes up to 300 degrees. And that is hard crack stage, and that's what we use to make lollipops. And then finally, you get to caramel. And that's past 300 degrees, usually about 310 degrees, and it starts to color. And then you can continue to cook it until it gets caramel in color. You smell it. We're going to do some of that with this too. Yes. And then that's how you can make caramels. Okay, so I have 3 pots of sugar going. The first one, this one, is for the Italian meringue buttercream. What I'm going to do is I'm going to cook this sugar syrup to about 238 degrees until what we call softball stage. Sorry. And the way in which you can measure the temperature is, the easiest way, obviously, is with a thermometer. You can just put a candy thermometer in here, and you can see as it slowly goes up and gets to 238 degrees. But the other way, and this is how many professional pastry chefs will do it, because we often can't find a thermometer in the house, is you actually take a cup of ice water, and you put your finger in it until it freezes your finger. Okay. And what you do is you dip your finger into the boiling sugar syrup, which is at 238 degrees, which would normally burn your finger. But if you do it quickly enough, and if you freeze your finger enough, then you don't feel it. And you swoop up a little bit of the sugar syrup, you plunge it into the ice water, and then you see what kind of ball you get. And so you do this until you get the soft ball, and that's how you find out if you're at 238. Now, the way in which I know that it reaches 238 is you can actually hear the difference in the boiling. When it first starts boiling, it boils just like water. It's just like a very fast, rapid clip. And then as the water starts to evaporate out, it gets slower and slower, and it sounds a little bit more viscous. Okay. So it's not quite ready, but I'm going to show you. Actually, I think it's getting there. So just put that in. And there, can you see there's a little bit of stuff falling off? But this isn't yet a softball. This is kind of sludgy. So still a little sludgy. It's like way too soft. It's not really a ball. But we're getting there. I can hear it. It's starting to get a little thick. Okay, I think we're there. So now I'm going to take some, stick it in here, and you can see you have a little ball, right? So this is, there we go. Whoa! Okay, so now I'm going to come over here, and I'm going to pour this into my egg whites. So this is similar to what I was doing before with the sugar and the egg whites, except for this time, instead of just plain granulated sugar, I used a sugar syrup that was heated up to 238 degrees. This is going to create a much, much more stable meringue than the one that I didn't heat up the sugar. So you'll see, I'll be able to show you the difference when it's heated up. So when you make buttercream, this is an Italian meringue buttercream. That's called Italian meringue. As this starts to thicken and get stiffer and stiffer, eventually it'll cool down, it'll stiffen to really, really stiff peaks, and then we're going to add a pound of butter, and that's what you guys are eating in your little cup. I mean, you all are eating like a tablespoon, so I think you're okay. Okay, so now what I have going on here is another pot of sugar that I've added a little bit of water, and we're just going to boil it, and we're going to make caramel. We're going to make praline. So I'm boiling it until it gets past the 300-degree mark. I have some nuts. This is like the easiest dessert that you can make at home, assuming that you feel comfortable making caramel. But you just put sugar and water in a pot, you bring it to a boil, and let it keep boiling and boiling and boiling. And this is now way past softball stage. If I stick my finger in now, I'll probably get a firm ball, and it'll slowly start to color on one side. You'll start to see that it's going to get a little bit caramelized. And you don't want to touch the pot until you see it starting to caramelize. But once it starts to caramelize, then you can touch the pot and you can move it around. And then as soon as it gets to a really beautiful glossy caramel color, then we're going to add the nuts. We're going to pour the nuts out onto this sheet, and then it'll cool. And once it cools, it's going to cool hard, and it'll be a praline. It'll be a almond praline. And just so you know what's going on here, this is, again, more sugar with a little bit of water, bringing it all the way up to a boil. We're going to bring it to the same stage as the praline caramel, and then we're going to let it cool a little bit, and then we're going to make what's called spun sugar. Spun sugar takes advantage of the fact that once you take sugar to that certain point, and as it starts to cool, it actually starts to thread. And you can take the thick sugar that has resulted from the sugar syrup getting all of the water boiling away, and you can take advantage of that and actually fling it across a dessert like this croquembouche. And then you get to create what's called spun sugar, which is these gossamer, silk-like threads of sugar that are really beautiful and really delicious and also very fragile. Trying to do this, you want to do it ideally as soon as you're going to consume it as possible, because depending on the weather, it'll last maybe an hour, but it probably won't last much more than 3 or 4 hours. Okay, so this you can see now. I don't know. Do you want to do this one? I'm going to let that one go, because this one is getting a little close. Yeah, you can see. So now you can probably smell the caramel. So I'm going to let that caramelize. While that's caramelizing, I'm going to show you this Italian meringue. So the thing with Italian meringue is that when you whip it that way, it's so stiff that you can turn the bowl upside down and it won't come out because you've created such a strong structure for that meringue. And then at this point, to make Italian meringue buttercream, I'll turn this back on, and then I'm going to start throwing the butter in here. I'm actually going to go back and forth between making sure we don't over caramelize this. A little bit longer. And you want room temperature butter. Butter that's soft enough that you can kind of peel it off in chunks and allow it to slowly absorb into the meringue. Okay, we're putting that on pause. We're going to throw in the almonds. My hands are covered in butter. And then dump it out. And then spread it out. So while it's hot, it's obviously very dangerous, but you've got a short window of time where you can spread it out, and then it starts to cool. So by the time this class is over, which will soon, this will have hardened, and you'll be able to taste it. I mean, we don't have enough for everybody, but we'll break it up, and some people will taste it. Okay, so that's the praline. Coming back to the buttercream. And this is our Italian meringue buttercream. So this is what you would use to decorate a wedding cake. You can use it to top cupcakes. But it's a beautiful, beautiful buttercream that you can use. And you can make it ahead of time and then use it for all of your cakes. So that is using sugar at 238 degrees to form an Italian meringue. Now I want to show you these two meringues so you can see how this one has, I don't know if you can see there or here, but it's all started to kind of fall apart, right? Because there's no sugar, and so all of those air bubbles that we formulated in here are starting to break down. But then if you take this one, it's still nice and stable. And that's because of the sugar and how it protects all the egg foams. And then we have one last thing is this. So this is the sugar that was boiled, and it's now caramelized. It's a nice, beautiful golden brown. And now we're just going to wait for it. So if I take something in it now, you can see it's just falling off. It's dripping off just like water. So we're going to wait for this to cool and thicken, and then we're going to use that to spin sugar. Okay, I think we're going to take a pause real quick. So you can see that the syrup has started to firm up a little bit. And the reason why Harvard got this really nice tablecloth is because every year when I do this, it gets really messy, but it's really beautiful. And you just want to wait until the syrup gets a little bit viscous, and then you can use a fork or a knife, or I was trained just to use an offset spatula, and you just continue to, you let it fall off, and then I don't want to get your camera, I'm sorry. I don't want to get you or your camera. And you can take, this is called a croquembouche. The praline that's up here, I know from past experience, You're more than welcome to try. Some people will leave after the lecture, and some people will come up here and try to break off the praline, and you're more than welcome to. I'm going to tell you, however, that this croquembouche, it's not filled. Usually these are filled with cream, whipped cream, but it's not filled. And I do need it for tomorrow because it is the students' lecture tomorrow. And so I think one year I forgot to tell people, and I came back the next day and there was no croquembouche. Everybody had eaten it, but there wasn't even anything inside. I didn't understand the appeal, but it's not going to taste good, so try not to take it.
Okay, so I think we could stay here all night asking more questions. But how about we officially end here, and you can come up and ask more questions and test and try and hang out. And next week is fermentation with rich shea, koji molds. There are books in the back. Thank you for coming. And let's thank Joanne one more time. Thank you so much.